A startling discovery by the James Webb Space Telescope, JWST, has sparked widespread intrigue. Scientists have detected what appears to be artificial illumination in deep space, roughly 7 trillion miles from Earth. The telescope focuses attention on Proxima Centauri b, the nearest known exoplanet to our solar system, and observed unusual bright lights emanating from its surface. These lights resemble the glow of urban development, raising the tantalizing question: could this be evidence of extraterrestrial life? The observation has reignited interest in the search for intelligent life beyond Earth. For years, researchers and space enthusiasts alike have speculated about the existence of civilizations elsewhere in the cosmos. Now, a potential sign has emerged. While surveying the universe, JWST captured shimmering, city-like lights on the night side of Proxima Centauri b, a phenomenon that seems to suggest the presence of a distant, alien metropolis. This possible glimpse into an off-world civilization has left scientists both astonished and curious. If proven to be real, it would indicate that intelligent beings may be constructing complex infrastructure in space, entirely unknown to humanity until now. NASA engineers are now asking, how long have these lights been glowing in the void, waiting for us to develop the tools to finally see them? Dr. David Kipping, an astrophysicist at Columbia University, finds the Proxima Centauri system particularly compelling. He notes that the planet exhibits thermal behavior unlike that of typical rocky worlds. Whereas most such planets absorb sunlight and emit infrared radiation in predictable ways, Proxima Centauri b displays unusual infrared characteristics that don't align with its host star. These anomalies caught JWST's attention, as the telescope excels in detecting infrared frequencies, helping scientists investigate the exoplanet's thermal patterns and possible atmospheric conditions. With its unmatched sensitivity, JWST can detect even faint emissions of light on a planet's night side, an incredibly difficult task for most instruments. It is uniquely equipped to verify whether the lights on Proxima Centauri b are of artificial origin, since it can detect signals within a frequency range 1,000 times dimmer than starlight. Interestingly, Proxima b appears to have surface features with potential technological implications. On its sunlit side, researchers suspect the presence of structures, possibly massive solar arrays, capable of absorbing energy from its star. As Proxima b completes its 11.2 Earth-day orbit around Proxima Centauri, it experiences cycles of heating and cooling. If the planet lacks an atmosphere, these temperature swings would be extreme. However, if an atmosphere exists, it could moderate those shifts, something JWST is now attempting to confirm. Understanding these fluctuations is crucial. If Proxima b does have an atmosphere, scientists can begin studying its chemical composition. The presence of gases like methane, oxygen, or water vapor could point toward habitability, or even life. But this is no simple task. Extracting data from light that filters through an exoplanet's atmosphere requires incredibly precise instruments and analysis, and even JWST has its limits. It can only deeply investigate a select number of nearby exoplanets. That's where the next generation of observatories comes in. Ground-based telescopes like the upcoming Extremely Large Telescope, ELT, expected to begin operations in 2028, will further advance this mission. The ELT aims to dissect the atmospheric structures of faraway exoplanets, offering richer insights into their potential for life. In the meantime, JWST continues to serve as our most powerful eye in space. Despite its limitations, it remains a crucial asset in the quest to decode the mysteries of alien worlds. Astronomers are also developing innovative strategies for future telescopes, such as internal light-blocking masks or external spacecraft star shades, to dim the overpowering brightness of host stars and allow better observation of planetary atmospheres. Even so, detecting signs of life is no straightforward task. Scientists must distinguish between gases produced by living organisms and those generated by natural geological processes, like volcanic eruptions. The path forward is challenging but promising. JWST offers just a glimpse of the extraordinary breakthroughs awaiting us. As our tools improve and our curiosity deepens, we inch closer to answering one of humanity's most enduring questions. Are we alone? Despite decades of searching, we have yet to discover definitive proof of life elsewhere in the cosmos. And yet, our quest continues. led by powerful instruments like JWST and supported by institutions such as the SETI Institute, founded in 1984 by astronomers Jill Tarter and Thomas Pearson. Their mission to identify extraterrestrial signals remains as vital today as it was then. The universe may still hold countless secrets, but with each observation, we edge closer to revealing the unknown, and perhaps to making first contact. Radio signals from space and the search for alien life. Radio waves have long been the focus of deep space exploration due to their ability to travel immense distances without being scattered or absorbed, unlike many other types of radiation. This makes them ideal for detection by instruments like the Allen Telescope Array, a network of 42 radio dishes nestled in California's Cascade Mountains. For over 3 decades, the SETI Institute has used this array to scan the skies for potential signals from alien civilizations, yet no confirmed transmissions have been received. Still, astronomer Jill Tarter remains hopeful, advocating for greater public involvement in the search for intelligent life beyond Earth. The quest took a new turn with recent NASA reports suggesting that the James Webb Space Telescope, JWST, may have detected what looks like urban lighting on a nearby exoplanet. This marks a potential breakthrough in humanity's effort to uncover evidence of extraterrestrial intelligence. James Webb Space Telescope, a game changer, launched in December 2020. The JWST is the most advanced infrared observatory ever built. Designed to peer through cosmic dust, it reveals hidden corners of the universe and investigates the formation of the earliest galaxies and stars. Named after James E. Webb, a pivotal figure in NASA's Apollo era, the telescope is equipped with a cutting-edge suite of instruments: NIR-CAM, near-infrared camera; NIR-SPEC, near-infrared spectrograph; MIRI, mid-infrared instrument; FGS, fine guidance sensor, which keeps the telescope perfectly aligned while tracking distant targets. Its massive gold-coated mirror, composed of 18 hexagonal segments, was engineered to capture even the faintest light from ancient galaxies. Operating at ultra-low temperatures, the JWST can also detect weak thermal emissions from remote planets and stars. Since its deployment, JWST has delivered stunning imagery and transformative data on galaxies, exoplanets, and stellar phenomena. But among its most surprising observations is the detection of city-like lights on Proxima Centauri b, a nearby Earth-like exoplanet. This discovery has sparked renewed scientific curiosity and speculation. City lights, or natural phenomena. The observation of lights resembling artificial illumination on Proxima Centauri b has left scientists stunned. The regularity and intensity of the glow rays questions about whether it could stem from technological activity. Some theorists argue it might be evidence of an advanced civilization, or perhaps luminous organisms with unknown bioluminescent properties. Still, other experts remain cautious, suggesting these patterns could be the result of rare natural processes. Unusual atmospheric conditions, turbulent weather, stellar radiation, or magnetic activity could be responsible for generating light that mimics artificial sources. Complex chemical interactions within the planet's atmosphere might also create optical effects visible to JWST sensors. What's next? To uncover the truth, scientists will continue monitoring the emissions to see if they repeat or display structured behavior over time. The JWST's ability to perform long-term, high-resolution observations makes it ideal for this mission. Whether the lights are signs of intelligent life or unfamiliar natural forces, this discovery pushes the boundaries of what we thought possible and brings us one step closer to answering one of humanity's oldest questions. Are we alone in the universe? In a context tied to technologically driven phenomena, such as electrical grids or engineered infrastructure, ongoing monitoring remains vital and may ultimately yield decisive clues to solving this enigma. At the same time, advancements in scientific instruments and techniques are paving the way for even more precise investigations of exoplanets. Upcoming space missions and cutting-edge observatories like the Extremely Large Telescope ELT will bring powerful new capabilities for detecting planetary signals and collecting data that complements the insights provided by the James Webb Space Telescope JWST. Together, these platforms are forming a collaborative framework for deep space exploration, one that could eventually verify the existence of extraterrestrial life or significantly expand our understanding of alien environments and their potential for habitability. As the search for life beyond Earth accelerates, the concept of identifying intelligent civilizations through analyses of distant planetary illumination signals marks a bold new frontier in scientific inquiry. Although we have yet to confirm alien life, each anomaly, be it an unusual radio transmission, unexplained light, or a strange cosmic pattern, brings us a step closer. The implications of discovering life beyond our planet will be profound, reshaping science, philosophy, and society at large. A realization that humanity is not alone in the universe could revolutionize our self-perception, and the detection of advanced civilizations might herald a transformative era of shared knowledge, cultural exchange, and possibly even interstellar technological collaboration.